Hello, this is Matt from Montoursville, KC3FOW Ham Radio. I am bringing this video to you today to talk about the MMDVM project, and specifically in the context of this video, it will be to convert your Yaesu System Fusion DR-1x to an MMDVM type of repeater. You might ask yourself, what is MMDVM and who cares? MMDVM was a project conceived by Jonathan Naylor, and it basically is the whole concept was to be able to create a modem that would receive and transmit on different modes that were programmed to it. P25, which is a digital radio mode, DMR, Yaesu System Fusion, D-Star, probably a couple other ones as we speak that are being developed for it. The components that are required for an MMDVM are an MMDVM modem board, a microcontroller of some sort, computer, and obviously a radio. And in this case, I'll be converting the Yaesu System Fusion DR-1x, which is natively created for the Yaesu System Fusion. I will be converting that to DMR. I also will enable Yaesu System Fusion on the MMDVM board as well to try to show you that. Now, what I've done in this video is I've broken some of the components out. I'm using the Arduino DUE, DUE, which is a popular microcontroller. I'm using Bruce Given's board, which is 1.0. I built it, micro soldered it with some special equipment, microscope, and some hot air rework tool, and created the board from blank. I ordered it, it came blank, and I ordered the components from DigiKey and soldered those, and I recommend that highly. It's a lot of fun to micro solder and put together your own boards. You get a better sense of satisfaction of actually building it yourself. But you can purchase it if you go to MMDVM.com. There's a new version of it, 1.01. There's specifically some errors on the schematic, but he talks about it in his parts list that he gives, and there's one section where there's polarity on a capacitor, I think it's C20, that's flipped around, so you have to read the instructions before you assemble. Anyway, this project's going to talk about how to do it, what are the pieces that I used, and feel free to use your own different parts and explore the MMDVM.com. There's a lot of smart people out there. In this case, this is going to just suffice to use the standard components that are commonly used in this project, and to convert the Yaesu System Fusion repeater. You might ask, well, why should I convert the Yaesu System repeater into DMR or any other mode? And the answer is it's a great repeater, but it's not being all that it can be, and you can really expand its abilities, and it's a wonderful repeater for the price. It just, Yaesu System Fusion and all the firmware updates and things to make it stable, I think Yaesu could have done a better job, but that's just opinion. At any rate, I think you'll enjoy this project if you're a ham radio operator, and we'll get right into it here. So without further bloviating, I will start and give you some more information. Delving right in, this is the first screen of the DRX1, fixed FM on both sides. Second screen shows the frequencies and the power. Third screen shows the uplink and the deviation mode, transmit power. Fourth screen is important, remote is on, the rest are off. Fifth screen, again, the wide and low power, just to keep showing you there. And let's see what else we got. Okay, so the trick here is to use in this screen here,
is to use the packet mode of 9600 baud. You have to click on the top number there, the uplink, and choose 9600 baud. You'll see your DRX will change to the baud rate that you desire. Next, you have the ZUM board picture, and the right hand side is a connector. Now you have a different view of the ZUM board, and you see both receive and transmit pots. As you can see on this board, it's a lot of small parts and a lot of micro soldering, but it's fun. At any rate, there's two potentiometers. This one here is the one that you will turn the volume received, and the other one here is the one you will adjust. This one is critical, and when you are adjusting it, you will turn it like it's a well, you got to focus like a sniper, if you will, and turn it a gnat's leg width each time and key up your radio. That is the way I tune mine in. A quick note on port forwarding: you'll need to forward your cable modem's ports so that when you talk with the Raspberry Pi to the desired network, specific ports on TCP/IP need to be opened and forwarded back to your device. If you don't have that set up, then you will get no response, and you'll also have trouble maintaining the connection. So static your IP address on your Pi if I was you, and look into port forwarding and or demilitarized zone for the device. Here you're going to notice that the pins on the ZUM are from left to right 1 through 6. Next, you'll notice the picture of the ZUM pinouts itself. Now what you're going to see here is that there's the green line from 10 to 5 to 1 to 11. They're all ground. So ground is ground the world around. And you notice that on that connection, that pins 3 and 4 are also tied together to that. The left hand side is the DR-1x Yaesu Fusion. The right hand side is the ZUM. Make sure that you have those set properly. And although you'll see some other conversations about pin 6, you want to use pin 7 for the purposes of this video and installation. Eric Osterberg, who wrote this diagram, wrote pin 10 and 15 to show that you can power the Raspberry Pi directly from the repeater's pinouts. There's a 12 volt DC that you would have to purchase a transformer to transform that down to 5 volt DC to power the Pi if you so desired, and you can go into a set of pins on the Pi. That's what that piece of diagram is. I personally power my Pi through a transformer directly into the wall, but I think his option there is really more efficient. I may change to that. Let's talk quickly about the recipe of hardware and software ingredients you need to get started. For all intents and purposes, you can use whatever microcontroller and computer you want, but it has to be on the supported list. And the supported list, if you go to Git Hub and you type in MMDVM project, you can pull up the specs on the MMDVM project. Anyway, let's start out with what I used. The Raspberry Pi 3 is a small microcomputer. It's about the size of an index card. It has 4 USB ports. It has built-in HDMI video. You have to have a cable to talk to an HDMI video source, and it needs a power supply. It's 5 volts. And you can purchase this thing in a kit. Typically the board and the power supply, you need a keyboard and a mouse. So I got the little the kit that has the wireless keyboard with the mouse pad. It kind of sucks, but it works. At any rate, the other thing you need for the Pi is a SD card. It plugs into the bottom of the Pi. It's called a micro SD card. I got a 32 gig one, and let's take a look at that. I got one of these SanDisk 32 gig micro SD cards with the adapter that plugs into my computer, and my computer will see it as a drive. And you can burn an image to that Pi, which is you download the image. I made an image of my own. I'm going to be including it in the description. You can download my image if you like, or somebody else. It doesn't matter. I use Raspbian, the latest version, and I put a few other utilities on it as well. So the Pi, the card, and you're going to need some kind of a microcontroller. The microcontroller that's the most popular right now, I think, for the ZUM board. The ZUM board actually is physically fits on the top of this like a cape. It plugs into the top of this Arduino microcontroller, and the two of them together create the modem. You have to flash the Arduino microcontroller with the firmware that's created. You have to compile it and flash that, and it creates a modem. That the microcontroller with the ZUM board creates a modem, and you can use different microcontrollers. There's some development for an ST out there, and for the intents and purposes here, this Arduino DUE, DUE, is what you look up in eBay. And if you go to MMDVM.com, this is Bruce Given's site. He created the ZUM board, and then you click on the products and pricing. You'll see the newest ZUM board is called the 1.0, and he offers the whole thing together if you want to buy the deal together for $85 in shipping, or just $60 for the 1.01 version. 1.01 is the newest version. I have the 1.0. The 1.0 required a clock on certain situations, and the clock circuit was to keep the Arduino DUE in time. So those things are needed. Plus, if you want, an option is the retail SDR. This is a SDR radio that typically is used to surf the airwaves and view the signals and what is looking like the whole spectrum. It's a spectrometer, if you will, for radio. You can tune into different circuits. I'm using this to tune the card, the ZUM board, because the ZUM board has potentiometers on it that need tuned. Here is the Win32 disk imager program that you use to do the flashing of the SD card for the Raspberry Pi. So you download the image, you download this program here, install it, and you burn that image to the drive letter that appears for your SD card. And then you take the SD card, plug it into the Pi, and boot the Pi up, and life should be beginning for you for your project. So next we'll talk about the other steps.
Okay, here's the Raspberry Pi hooked up to the Arduino DUE with a ZUM board on the back. I don't have the cable plugged into the repeater. This is just the bench portion of it. I'll show you at some point with it hooked up to the repeater, but here's the Arduino DUE and the ZUM. Over here's the Pi. If you notice, I can show you that I have the retail SDR 2.0 version with this little antenna hooked up, and I've got an extender cable hooking from the Pi all the way to the programming port of the Arduino DUE. The HDMI cable and the power cable to the Raspberry Pi. The HDMI hooks up to the monstrosity of a monitor that I have here mounted on my wall, and I made an image, and basically what I've done here is pre-canned everything so that you can just basically flash this image and you'll have this nice little logo, and it has the start button. It looks like a ZUM board. I'm trying to customize it, and I'll probably customize a few more of the icons, but all the utilities that you need, the Arduino DUE utility, so you can plug your Arduino right into your Pi to do the firmware flash. You can edit your MMDVM, you can do the calibration, the background service and the start. So there's different pieces of it. There's a Chromium web browser. I've renamed it a little bit. I called it control panel, Pi utilities. I kind of use my own terminology because I was trying to minimize all the garbage that they had on the other image. I took an image from the DMR UTOL and I added the MD380 tool so you can flash the MD380 DMR radio with the current version of the hack software from a guy by the name of Travis Goodspeed, I believe. And it's an awesome package to overwrite the firmware on your MD380 or your 390 so that it'll have extra capabilities. Also included the retail SDR spectrum analyzer. It's called Freak Show, FREQSHOW. That will allow you to tune it in, tune the ZUM board's potentiometers right here into the proper frequencies, and the update the flash on, if you have a 380, to update your flash, use your CSV. So start out, you're going to want to, when you get this image, you're going to want to join your Pi to the network that you have. Mine's called Sputnik. I joined it. It's using the Wi-Fi interface right now. What you'll want to do is you'll want to Google how to set a static IP address on a Raspberry Pi, and actually probably hardwire, but you don't need to. I mean, it's just, I do that, and then I forward ports from my router to the hardwired connection. I just think it's much cleaner. Once you get this all set, you're going to have the VNC service that actually starts, and you'll notice here's an IP address that you can use. If you got it on your network, you can use this IP address and have the VNC viewer on your Windows or Linux computer and remote control the Pi from there. So that's what we're going to do for now. I'm going to connect to this 192.168.3.123 on port 5800, and I'm going to remote control this thing so that we can continue on.
Okay, here I am upstairs. I'm remote controlling the MMDVM through a program called the VNC Viewer. You will download the VNC Viewer from the internet. I'll Google that, download it, install it, punch in the IP address of your Pi that you've determined, and then you hit enter, and then it'll ask you to connect. The username is Pi, and the password is Raspberry. Okay, and you'll get to the MMDVM, to the Raspberry Pi screen. And the first thing you'll want to do is check your time and set your time and date and things like that. It's all in the control panel under configuration, the Raspberry Pi configuration, your locale, etc. Set locale. Make sure that if it's going to come set for East Coast time and USA and everything USA instead of the UK. And the next step you're going to initiate is you're going to have to, what I would do is the update all feature here under the ZUM modem section. When you do an update all, what it's going to do is it's going to talk to the GitHub, and it's going to get the latest, greatest code. And here we go with the latest, greatest code. Here we go. It's downloading it, and it's thinking hard. And then the next step you're going to do once you've downloaded the latest, greatest code is you're going to flash the latest firmware to the MMDVM modem, to the Arduino Do. And to do that, we'll show you here the Arduino Do pieces of the software that are on this image. And basically, if you have the cable connected to the Pi and to the programming port of the Arduino Do, this is going to work out for you. You should be able to flash the latest, greatest firmware, and then begin begin playing, editing the other files. So we're going to let this go through. I'll come back with this video when it's done. All right, so now the update ensued and it just closes the terminal window. And the next step you want to perform is an update to your Arduino Do. This will flash the firmware that's on your Arduino directly to the Arduino to make the modem. Basically programming the Do to talk to the ZUM board that's on top of it, and hopefully this thing will kick into high gear and show us everything. So yeah, here's the code that is downloaded from that update, and the Do is already set up for you to talk to your the Raspberry Pi. What you want to do here is you'll want to do a compile and upload this program. You just hit this arrow, and it should talk to the. Notice at the bottom of the screen there it says Arduino Do programming port on dev TTY ACM0. That's the programming port on the Arduino Do. If you don't have it hooked up to the right port, you won't see this, and really need to have it hooked up to that port. It's the one in the video to the right if you take a look at the hookup again. So you just hit upload, and then it'll start compiling, and it might come up with this crap here, and you can just close that out. Basically, you just want to use the version that when they wrote this program, it was written for a specific version of the Do and the Arduino software. There's different versions of this Arduino IDE interface, and you want to use the version that is most compatible with what you're doing. So, at any rate, moral of the story here: compile it by hitting the right arrow, upload, and then bingo, it'll flash the newest version of the software, and you'll be good to go. I already have the version that's most new on this image as of today, February the 5th, 2017, and should work out for you. Once you get that flashed, at that point, the Arduino is ready to rock and roll, and then the next step you're going to do is go into the configuration of your ini file. You're going to change the call sign to your club or your repeater call sign, your frequency, your transmit and receive frequency on the repeater. In this case, I have it at 439, and receive and transmit on the repeater is 434, and the latitude and all that stuff. The height, I think, is necessary for the Brandmeister network. You go to Brandmeister and it talks to Brandmeister. If it doesn't have a height, it doesn't think you've got it doesn't think you have an antenna, and the power as well. So those two things are kind of important. Then you have the ports and things, but you can leave this alone per se, except for the part of your ID. There's my ID for my repeater, and go through here and enable the other features. I have the System Fusion network turned on, the P25 network fired up, and it'll use this Nextion display if you want to hook a Nextion display up. So there you have that. Once you've got the MMDVM ini set up, the next step you want to do is a calibrate tool. So you click the calibration, and this thing should launch. I must have if it doesn't launch, then you know there's another problem. We're going to stop the host. Must have the background service started. So hit stop. I'm going to stop both the the program from running. Once that's stopped, basically should be able to run the calibration tool. Come on, calibration. There we go. So if I'm into this and I'm in front of the modem, you can toggle on and off the transmit, and you'll be able to see your lights flash and things should show. And you can actually tune in with your, at this point, you can tune in and use your retail SDR tool and watch the signal that's coming out of your radio, because there's a tone that's going to be playing on this calibration tool, and you can tune it in that way. I did it the ghetto way. When I did mine, I held in the transmit on my radio and just kept tweaking the transmit pot very slowly until I started seeing activity on the terminal screen on the MMDVM host program, which I'll show you here. I'm just going to quit this, Q for quit, go into the MMDVM software here, start, or you could do over here, you can do this one. I put a little shortcut to do start. Hopefully that's going to work. I don't know. Let's see. Oh, there you go. Okay. So there it goes. I just create a little shortcut there for people because sometimes the menus are a pain. Well, at any rate, here's where you can actually watch your radio if it's talking to your repeater properly. You're good to go. This is it.
Here's what you're gonna hear when you try to transmit and your repeater is not functional, or is not well, it's functional but it's not synchronizing. This is kind of what it sounds like. You hear the tick, tick, basically that is a situation where it's not talking to the MMDVM, or the MMDVM is not running, and you may be seeing a CB KS something or other on the screen is down. A couple reasons for that. You have to check your MMDVM settings, but the reason that was my problem was that the transmit pot was not tuned properly, and it takes a little while to tune it in, and a lot of patience with it as well. You've got to tune it like you're just kind of adjusting it a gnat's leg width each time you turn it to the right, so it's a real, you can't breathe too heavy when you're tuning it. Just to give you a sample of how sensitive that potentiometer is. Okay, on this video I'm going to show you how the ZUM reacts and what happens on the screen, so you can see successful transmission. First of all, I'm going to use my radio here to pick the contacts, and I'm going to scroll down, and I have the Echo Private is what I have it called, and I'm going to make a call to that. Here we go. This is KC3 FOW testing, KC3 FOW testing. Okay, now watch. The screen is rolling.
This is KC3 FOW testing, KC3 FOW testing.
And here's the ZUM board. Both lights are on. It goes off. That's proper transmission. Here's the front of the repeater. As I key up, watch what happens. There's a transmission going on right now. Here we go. I'm going to choose my contact again, and I'm going to do Echo Private. This is KC3 FOW testing. KC3 FOW testing.
FOW testing, KC3 FOW. Adirondack Lake, just on the other side. You can hit Bennett Road is the first road after Adirondack Lake. That's the road my parents' house was on. We still go to the Adirondacks every year. Every summer we go